we're gonna also talk about the periodic table trends. And guys, when we say periodic table trend, we're going to be talking about ionization energy. First, we're going to talk about atomic size. Then we're going to talk about ionization energy. So ionization energy. Guys, the energy symbol sometimes is like that as well, okay? And then the third one we're going to talk about is electron affinity. So guys, I would expect at least one question on each one on the exam, okay? So electron affinity. So guys, three terms. Let's talk about each one at a time. The first one is atomic size. So guys, we basically need to look at the periodic table and decide what happens to the size of the atoms when you go from left to right. So the question is, when you start from the left-hand side of the periodic table, let's say hydrogen and then helium. So I want you guys to tell me which one do you think is going to be bigger in size? So which one is larger in size? So again, try to think in your head. What do you think? Who is bigger, hydrogen or helium? So if you're thinking it's helium is a bigger one, then actually that's not right. Helium is actually smaller than hydrogen. Now, we might be thinking as hydrogen has one electron, proton, and then helium on the other hand has two protons, two electrons. It has more stuff in it. So if helium has more stuff in it, why is it not larger than hydrogen? Because guys, the factor that plays more important role is the number of protons. Okay, so let's take a look at that. So guys, when we try to draw an atom, in the center we always draw the nucleus, which is protons and neutrons, and then we have the electron sitting outside. So guys, tell me first, what is keeping this electron stay in the atom? Why does this electron not just leave the atom? The reason is because the center is positively charged. So if we look at our center, a center is positive and electron is negative, they're getting attracted to each other. So that's why electron stays in the atom and does not just leave as it is. Although you can force it to leave by putting in some energy, and we're going to talk about that in ionization energy. But the electron is trying to stay inside the atom, okay? Because of their charge, and this is called the nuclear charge. There's the attraction between the positive and negative charge, keeping the electron inside. So guys, think, if I increase this charge, if I increase this positive charge, what will happen? This electron is going to feel more attraction. And if it's going to feel more attraction, it's going to be attracted closer to the center. And guys, if your electrons sitting outside are being attracted closer, then what is happening? You're basically shrinking your atom. So atomic size will go down if your number of protons increase. And guys, in this case, we're only going to compare apples to apples, okay? So do not compare hydrogen to lithium. So if you see hydrogen is sitting here on the periodic table, so let me erase that part as well. So in the center, hydrogen has one electron. So this is hydrogen. Then I have lithium here, and then I have helium here. So helium has two protons. So in the center, it has two positive charges, and it has two electrons. But the point is that hydrogen is 1s1, and helium is 1s2, and lithium is 1s2, 2s1. So the point I'm trying to make is that hydrogen and helium both have only one floor, 1s1, only first floor, 1s2. Although helium has two electrons, but still just one floor. But helium has two positive charges. So if you remember, if you got more positive charge in the center, meaning you got more protons in the center, the electrons will feel more nuclear charge and they will be attracted inwards towards the center of the atom. That's why helium size is going to be smaller than hydrogen size. So guys, what we can say is, as you go right on the periodic table, as you go towards the right, the atomic size decreases. Okay. Now, when you go from top to bottom, so let's compare hydrogen to lithium to sodium, okay? And sodium is 11 electrons. This guy is 1s2, 2s2, 2p6, 3s1. Okay, so that's our sodium. Let me write this again, guys, just to make sure this is not confusing, okay? So hydrogen, lithium, and then we have sodium. Sodium with 11 electrons is 1s2, 2s2, 2p6, 3s1. So as you guys can notice, lithium, it has how many positive charges in the center? 3, because its atomic number is 3. And sodium, on the other hand, is 11. So sodium is 11, lithium is 3, hydrogen was just 1, and helium was 2 protons. I'm talking about the protons, okay? So lithium has 3 positive charges. Sodium has how many? Sodium has 11 positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. 11 positive charges in the center. And then lithium has 2 fluors, 1s2 and 2s1, so 2 fluors. And then sodium has first fluor, second fluor, but also has a third fluor. So if I compare hydrogen, lithium, and sodium, although my number of protons are going higher, so you might think, okay, with the same concept that if you increase the protons, like in hydrogen, helium, since helium have more protons, it should be smaller. So if I'm going down and sodium has more protons, it should be smaller. No, that's not the case. Why is that not the case? Because number of fluors are different. You're not comparing apples to apples. Hydrogen, helium is apple to apple comparison. Hydrogen to sodium is not, because hydrogen has only 1 fluor, lithium has 2 fluors, and sodium has 3 fluors. So of course, if you have more fluors, that atom is going to be bigger. Okay, so as you go down on the periodic table, atomic size increases. So if I go back to the periodic table and try to label this, so if you go from the left-hand side to the right-hand side, what happens to the size? Size decreases. What happens to the size as you go from top to bottom? Size increases. Okay, so yes, potassium is bigger than sodium. Francium is bigger than cesium, and all these atoms on top. So guys, if we try to understand this, which one is the biggest atom on the periodic table? So see, anything, anything, see, if you go left to right, things are smaller. That means things on the left-hand side are bigger, right? And as you go from top to bottom, the bottom ones are bigger. So if we see anything that is on the far left and the very bottom, which is francium, is going to be the biggest atom, the biggest one of all. And if I ask you which one is the smallest one, then you see the one on the top are smaller, and as you go right, they get smaller and smaller. So anything that is on the farthest right-hand side and on the topmost side is going to be the smallest one. The smallest atom on periodic table is helium. The biggest one is francium. Okay, so guys, I hope that makes sense. The kind of question you're going to see on the exam is where I'm going to put, okay, tell me if I give you sodium. So let's do that here. So on the exam, if I give you sodium, magnesium, so sodium, magnesium sitting right next to each other, and then I give you chlorine and potassium. So let's look at these 4 guys: sodium, magnesium, chlorine, potassium. Sodium, magnesium, chlorine, and potassium sitting here. So tell me guys, which one do you think is going to be the smallest, and which one do you think is going to be the biggest? So first of all, what we already know is things that are on the right hand side are the smallest, and things on the left hand side are bigger, and things as you go down are going to be bigger. So let me show you that again. So as you go to the right, things get smaller. So chlorine must be smaller than magnesium, and magnesium must be smaller than sodium, right? And then if I ask you between sodium and potassium, which one is going to be bigger? Potassium is going to be bigger, because as you go down, size is bigger. So if I start from the smallest to biggest, who is going to be the smallest one? Chlorine is going to be the smallest one because it's on the far right hand side. Okay. Next is going to be the one which is on the left of chlorine, which is magnesium. And the one bigger than magnesium is going to be sodium. And then the biggest of all is going to be potassium. So guys, you should be able to do something like this. Is the increasing order, you're starting from the smallest and going to the biggest. Okay, all right. Now, let's talk about the next thing, guys. The next thing we're going to talk about uh, is the ionization energy. Okay, so ionization energy is dependent on atomic size. So first of all, what is ionization energy, guys? It's the energy required to remove electron from an atom. Okay, so if I have an atom like hydrogen, and then I have another atom like helium. So what I'm trying to show you is helium is smaller than hydrogen. So this guy has electron sitting here, and this guy has its electron sitting here. And you know, center is where the positive charge is, right? So who do you think, guys, is going to be more difficult to lose its electron? So is hydrogen going to be the one who loses the electron, or is helium is going to be the one more willing to lose the electron? This is going to be based off the size. Now, guys, you're going to see a little more detail of this when you go into Gen Chem, if you're going to take Gen Chem ever. But in this class, we're just simply going to base this off the atomic size. See, as the atom will get smaller and smaller, the electron is getting closer to the center. So it's feeling more positive charge from the center. If it's feeling more traction from the center, it's going to be difficult for us to remove that electron, right? So if I have a positive charge here and a negative charge here, on the other case, I have a positive charge here and a negative charge here. It's going to be difficult to remove this electron because it's so close to the positive charge and the attraction is very strong. It's going to be easier to remove this electron because it's very far from the positive charge. It's feeling less attraction from the center. So it's easy to remove this one. It's difficult to remove this one. Now, which one is which? Is this one hydrogen or is this one helium? See, when the atom is smaller, then the positive negative is going to be closer. So this is the example of helium, and this is the example of hydrogen. Okay, so helium is going to be more difficult to lose the electron. So if I ask you to put them in the increasing order of ionization, and guys, ionization energy is shown as IE. So increasing order of ionization energy, increasing meaning who is going to take less energy, guys? The one who is easier is going to take less energy. I have to put less effort to break to remove this electron. If it's difficult, I have to put more energy to remove that electron. So increasing order of ionization energy is hydrogen is going to take less energy. So it's going to be less ionization energy than helium. So helium takes more energy to remove the electron versus the hydrogen. Okay, so as you go to the right side of the periodic table, things will not want to lose the electron. So as you go to the right of the periodic table, like if I compare chlorine to sodium, chlorine does not want to give off its electron because it's on the right hand side. And we already know that, guys, if you remember from nomenclature lecture, that you have metals and non-metals. These guys want to lose electron. These guys don't want to lose electron. And we can confirm that from here, guys, of the ionization energy, that these guys do not want to lose electrons because they're pretty small. Their electrons are very close to them. And then here, it's easy for them to lose their electrons because electrons are farther away. And then, of course, we already learned why some atoms want to lose electrons, some want to gain electron because of the uh, um, how many electrons they want to keep, which is the 8 electrons they want to keep, okay? All right, so this was your ionization energy, okay? So again, if I ask you on the exam to put them in the order, you should be able to do that as well. Now, guys, just to summarize here, what is happening to the atomic size as you go from left to right? Atomic size was getting smaller. What is happening to ionization energy? Ionization energy is increasing, guys. So do you see that atomic size and ionization energy are inversely proportional to each other, meaning size goes down, but energy goes up. And if we go down, then again, guys, atomic size increases, or it's getting bigger. That's why ionization energy will decrease. Again, opposite. Size increase, ionization energy decrease. So ionization energy of francium is going to be less than the ionization energy of potassium, for example. Okay, all right. Now, the final last thing, guys, I want to mention here is the electron affinity. Now, guys, electron affinity is the opposite of ionization energy. So, guys, the word affinity means what? Affinity means love. So, who is going to love the electron more? The smaller ones or the bigger ones? So, guys, the smaller atoms, since their electrons are very close to them, they love their electron more. They do not want to lose their electrons. So, guys, electron affinity is going to be more as you go to the right. So, electron affinity increases as you go from left to right, and electron affinity decreases as you go from top to bottom. So guys, this is again just the opposite of, I mean conceptually opposite of ionization energy, okay? But if you think about the terms of the affinity itself, you can see electron affinity is increasing from left to right. Ionization energy also increases from left to right. But you're gonna later, guys, in Gen Chem learn that their signs are opposite, guys. Energies can be given sign positive and negative based off if you're adding energy or you're getting energy. If you're gaining, if you're absorbing, or you're releasing energy. Okay, so that's a different thing. We don't go into that much detail here, but you should understand the order of the electron affinity and ionization energy and the atomic size. Okay, so I hope, guys, that makes sense. We'll see you guys in the next video, okay?